cloning in this configuration, yeah. Yeah. Still turning it over in your heads. Yeah. It's okay, everyone in the room can ask the same question. It's good. Because maybe I'll come up with a better way to answer.
So like they're going through this process and instead of like going back to their own homes, so to speak, they
Yeah. Kind of. Let me think if I can. So it's like if we visualize this point right here, okay, actually breaking, right? And then it's rejoined. Does everyone kind of follow that point where it's broken here, and then this piece ends up rejoining with that. This piece is rejoined with that, and then it's also happening on this opposite strand. So this is coming up here and rejoining with that, and that's hard to draw. So this is when you have a crossover event only. Okay, so the second, this results in recombinant chromosomes. The first is not considered a recombinant, even though you have copied information from another chromosome. Other questions? Yes. I'm pausing because I know this is confusing.
This isn't the pathway though that would happen when we're normally doing crossovers during normal meiosis.
It's part of it, actually. Yeah. Yeah, but we're not.
Similar, but we don't see it.
Yeah, and that has to do with the holiday junction stuff, which we're not. Yeah. Because you guys can see how confusing this is to to wrap your head around just this, and so we're trying to keep it somewhat simple, as simple as this can be. What I wanted, I'll let you guys kind of keep thinking. I'm going to write another little thing up on the board here, and then if we have other questions, this is more because I thought you guys would find this actually interesting. Some of the, I keep writing in green here, proteins that do this, proteins that do that, proteins are involved in strand invasion. Some of the proteins that are involved, and you guys do not need to memorize this is more because I know folks are interested. Some of the proteins that are involved in this homologous recombination repair process you probably have heard of before. Anyone heard of BRCA1?
Breast cancer?
If not, you need to go read newspapers and think about it. This is a breast cancer gene, okay? A big time breast cancer gene. BRCA1, BRCA2 are one of the top reasons that women have breast cancer, mutations in these genes. Does that make sense? If these genes are involved in homologous recombination repair pathways, I hope that kind of clicks that you can end up with cancer if you have a whole bunch of double-stranded breaks that are not getting repaired if these proteins are damaged. Another big one, and this one I don't expect that many people to know, but it's called RAD51. RAD51 is implicated in almost every cancer known to humans. So RAD51 is another one of these proteins that's doing all this magical processing that we're talking about. BRCA1, BRCA2 are specific to breast cancer. RAD51 is almost every other cancer. So proteins that do these jobs, if you mutate them, okay, this is kind of like when we talked about Fragile X, and if you mutate, if you mutate proteins that are involved in repair systems of damaged DNA, you end up with a high accumulation of damaged DNA, and thus ending up with what clinically we call cancer. Surprised you haven't heard of BRCA1, BRCA2. It's like in the newspapers and a big deal, and many years ago they did. So they're trying to do cloning of Genentech in San Francisco does a lot of work with BRCA1, BRCA2.
I guess not.
It was just October. Everyone was running around with a little pink ribbon, hooray for boobies, but no one knows BRCA1, BRCA2. Come on. Okay, I will hang out. If you have questions about this process, this is super weird. Come ask me. Otherwise, you guys.
Shout it out.